Welcome to today's webinar. We've got a great one lined up for you here with John on wood manufacturing safety. And just want to do a few quick housekeeping things. We're going to allow you to put your questions in the chat as always, and we're definitely going to address those at the end. But we've got a smaller group this time, so there may be some opportunity for you to unmute and discuss your questions as well. So we're going to go ahead and encourage that. I'll let John kind of steer the boat on that as he goes. But slightly smaller group this time, but we're really excited about that. We're not all about just getting the numbers. We're about getting the information that is needed to the people who need it, and that's what we're trying to do here. Is we think this is some pretty targeted, specific information for your sector of manufacturing, and we wanted to make sure that we got this information out. So I'm just going to let John run with it. Don't forget to check out our other webinars. John will have a little bit of information on that, but wvmep.com/webinars. And John, it's all yours.
All right. Well, I'd like to welcome everyone. Before we get started today, I wanted to remind you about some other upcoming webinars that we have scheduled. And you can find the complete list of webinars and workshops in the events section of our website. Note that all these webinars, just like this one, are running from 11 until noon, unless otherwise noted, and they are free of charge. A little bit about myself. As Jamie previously mentioned, my name is John Frazer, and I'm the manager of Industrial Hygiene and Occupational Safety and Health at West Virginia University's Industrial Extension. I am a certified safety professional, and I've been working with the Industrial Extension team for more than 23 years. During my time, I've helped manufacturers identify hazards, I've helped educate their workers, and I've helped provide expertise to eliminate or reduce occupational exposures in the workplace. I'm located over in Hampshire County, which some of you know are in the Eastern Panhandle of West Virginia. And more specifically, I'm in Romney, West Virginia. So I am responsible for outreach as well as working statewide on safety and health projects. The WVU Industrial Extension partners with small and medium-sized manufacturers in West Virginia to support operational improvement and business growth. And I just want to share some of what we do before we get started. As part of West Virginia University, the Industrial Extension serves as the university's land grant mission and is housed in the Statler College of Engineering and Mineral Resources. As West Virginia's affiliate to the NIST MEP National Network, the Industrial Extension is part of a nationwide program of centers tasked with supporting the manufacturing community. This unique arrangement provides the Industrial Extension the opportunity to support our manufacturing community from a national, a state, and even the local level. So the Industrial Extension focuses on developing consulting services that reflect our clients' needs. We provide hands-on education. We work one-on-one with our clients to deliver practical solutions in the areas of workforce, occupational health and safety, management systems, operational improvement, advanced manufacturing, leadership development, as well as innovation and growth services. All of this is available on our website, and you can take a look at some of the things that we're doing around the state of West Virginia. So let's get started with what we are all here to learn. Welcome to this webinar titled Wood Product Industry, the top 10 most frequently cited violations. We all know that machines used in the wood industry are dangerous, mainly when we use them improperly or without proper safeguards. Workers operating woodworking equipment may suffer from lacerations, amputations, severed fingers, blindness. We know that wood dust and the chemicals used in the finishing of the wood products are health hazards. And workers in this industry can definitely suffer from skin and respiratory diseases. So the purpose of this webinar is to help wood product manufacturers provide a safe and helpful workplace. We're going to discuss the principal hazards of woodworking, at least the top 10 most frequently cited violations in 2020, and the methods for controlling the hazards. My hope is to help clarify the regulatory language and technical information covered in the standards relating to West Virginia's wood product industry. In the end, we will have created a compliance checklist for safety. So we're going to take each of the top 10 and create a checklist in those areas that everybody will have a chance to get. So the objectives today are really to arm you with some information, knowledge, skills needed to recognize, evaluate, and control. We'll mention that later, recognize, evaluate, and control occupational or OSHA's top 10 most frequently cited standards for the wood product industry. Again, we're going to create a safety compliance checklist and disseminate safety and health information. First off, I'd like to take a poll question. And I want to know how many of you conduct routine compliance audits of your workplace. Keep in mind that these are totally anonymous. We're not tracking who says yes and no, and that's fine. It looks like we're a little more than split on these. And I didn't know, since we do have, we have about 12 people on the call together. If somebody would like to take, somebody in that 88% would like to take a minute or two and talk about what it looks like at your company, what you're doing in terms of auditing and compliance inspections and so on, I'd be glad to let somebody unmute and do that if anybody wants to share that information. So they can do that now if you'd like. And if there's no takers, that's fine too. So, it's good to do auditing, right? And it's good to be out in the work, out in the mill and looking for hazards and those kind of things. And we're going to talk about some of the things that you might see, at least from the top 10. So we're going to move along here. Year after year, we know that OSHA, the Occupational Safety and Health Administration, they publish the top 10 most frequently cited violations for the construction and for general industry. What I'd like to do at this point is share the top 10 for general industry, which covers all manufacturing, including sawmills, dimension mills, and the wood product industry. So this data is from fiscal year 2020. It's the latest, greatest data we have. And if you look at the bar chart here, and you can see again, this is for general industry across all the United States, not just West Virginia. And you can see that that in 2020, if you add up all the numbers, there were 5,442 citations for general industry. As you can see, chemical hazard communication tops the list, and it accounts for over 41% of the overall citations, with machine guarding accounting for nearly 22%. So what's that say? I mean, that's 63% of the most frequently violated standards in 2020 came from the 1910-1200 standard, the chemical hazard communication standard, and the 1910-212, which is our machine guarding in subpart O. That would be an excellent place to start with OSHA compliance, right? To look at those two, because that's what the OSHA compliance officers are looking at when they go out to sites. The rest of the violations have to do with respirators, nearly 17%, lockout, tagout, almost 8% of the cited violations, forklift trucks, 7%, and fall protection, almost 6%. We know in the construction industry that fall protection would be at the top. So I just wanted to share what's going on in general industry as a whole. Again, HazCom and machine guarding being two big players in that. Now that we've reviewed a snapshot of the top 10 most frequently cited standards for general industry, I'd like to just take a minute and discuss hazard recognition and control. I'd like to, with any hazard, there's a hierarchy of control methods that are used. And if we use the foundation of industrial hygiene definition, we should be anticipating and recognizing and evaluating and controlling occupational exposures that are emanating from our workplace. There's that definition again: recognition, evaluation, and control. Once we identify a hazard, whether it's a machine guarding issue or something else, it could be exposure to silica, like in the picture here. It could be a point of operation of moving blades. We see that in both of those pictures, or caught between and crush hazard. We have to control the unsafe situation, and we can do that by using the hierarchy of controls. One is eliminate, right? If we can eliminate the hazard, that would be great. With a lawnmower, we can eliminate it by maybe, paving the area. We could use a different method of mowing the grass or buy grass that doesn't grow. Wouldn't that be nice? We can use substitution. We can substitute the chemicals. We can substitute the process. If we can make it safer that way, it's great. If we can't do those two, we want to rely on engineering controls. In a sawmill, we're talking about ventilation. We're talking about control booths that the worker will sit in to eliminate the dust exposure, the noise exposure, distancing themselves from the machine guarding hazard. So those are all engineering controls, which are great to do because they make it so that the workers don't really have to think about it, right? They remove the hazard. If we can't do engineering controls, we have to rely on administrative or work practices, right? Workplace practices. And these are job rotation to try to minimize exposure to air and noise. Doesn't always work real well, especially in a sawmill, because we can't really rotate different job levels and skills around the sawmill. But we can also use procedures like lockout tagout to control the hazardous energy. We can follow a work practice and an administrative control, and then we can do it safely. Finally, the last line of defense, as we all know, is personal protective equipment, safety glasses, steel-toed boots, maybe a hard hat, earplugs, sort of definites in the sawmill, logging, even in dimension mills. So we want to rely on that last because the hazard's still there, obviously. And the workers could be, if they forget to put their safety glasses on or they don't wear their steel-toed boots, the hazard's still there ready to get them. So I believe it is important to teach this idea to your frontline supervisors and hold them accountable for their people. Have everyone look out for safety and health. We want people to fix what they can and report what they can't. That can go a long way to hazard control. So as you can see, hazard identification is a crucial step in keeping your wood products facilities safe. And we can do a couple more things here I want to share with you. One is to keep your eyes open for safety hazards all the time, and everyone, not just the safety person. Vigilance is the key for staying safe. We don't want to get complacent. We don't want to ignore, wet spots and frayed wires and unguarded saws, maybe smoking equipment, for example. So we want to keep our eyes open. We want to fix hazards that we're authorized and qualified to fix, such as mopping up water from a recent rainfall, unblocking a portable fire extinguisher that maybe has some wood in front of it, and picking up objects in the walking and working surface area. We also want to report hazards for which we're not authorized or qualified to fix. These might be chemical spills or malfunctioning machines or equipment that are jammed and we have to do lockout tagout. We may not be qualified to do or authorized, so we might have to report that to let somebody else who is authorized take care of the equipment. And even suspicious packages, that might be something that we need to report. And then finally, we want to always be willing to consider changes to procedures, to tools, to equipment. We want to get our workers engaged and improve safety, right? That's really what it's about. So West Virginia, it's a wonderful state, and we are blessed, as all of you know, to have an abundance of natural resources. One of those resources is wood, right? And we know the forest product industry is evenly distributed across the state, with the heaviest concentrations in the South and Southeastern regions. Some of you are showing up on this map, I'm guessing, maybe all of you. So West Virginia boasts, high-end wood product companies, hardwood flooring, cabinetry, engineering products, furniture, logging, sawmills, dimension mills, you name it. It's a great resource out there, and we're taking advantage of it. And that's great that we have that renewable resource. So what I want to do at this point is really get into discussing the top 10 most frequently cited standards for the wood product industry. And I want to look a little deeper. Again, every year OSHA cites these manufacturers for hazards in the workplace. Well, if we use the North American Industrial Classification Code of 321, wood product manufacturing, that sort of includes everyone under that. And if if we drill down on the data, I want to go through the top 10. And we're going to go backwards, obviously, to start with number 10, and we'll work our way up to the number one most cited violation for the wood product industry. So let's start with number 10. And this is one of the things that we saw in the general industry, right? This was nearly 17% of the most frequently cited standards for general industry. And it shows up as number 10 for the wood product industry. 1910-134, that's in subpart I, that's where we have our respiratory protection standard. And this is something that, because it shows up here, it's probably in cabinet companies that are doing spray finishing and maybe places that are really dusty and wearing respirators as well, treating wood and so on. So what's the deal with respiratory protection? Well, we know that people use respirators, right? Workers, and almost all the elements of the respiratory protection program affect the respirator user. So elements that have more direct impact on the user would include knowledge of the selection criteria, medical evaluations, procedures for proper use, our fit testing that we have to do annually, and our maintenance procedures. How are we storing the equipment? So proper selection, and if appropriate, fit testing of tight fitting face pieces will assure what? It will assure that the respirator will provide adequate protection against the contaminants in the workplace. And we know medical evaluations are necessary to determine whether the user is fit to wear the respirator without adverse health effects. And we know that training on procedures for proper use and maintenance will assure that the wearer, that they are using that respirator correctly in a safe and helpful manner. So the medical requirements part, all workers have to be medically cleared to wear a respirator before use if it's required. And as you know, all respirators generally place a burden on the employee. Negative pressure respirators restrict breathing. Some of the respirators can cause claustrophobia, and some self-contained breathing apparatuses, although we don't see those in this industry, would be heavy, right? So each of these conditions may adversely affect the health of some of the workers who have to wear respirators, and therefore we have to have a physician or what we call another licensed healthcare professional needs to medically evaluate that employee to determine if they can safely wear a respirator. The employer just gets back a yes, no, you're either approved or not. But we have to have people who are medically cleared. The maintenance and care of respirators, the proper functioning is really important. Ensuring that the device doesn't pose a hazard. We have to come up with a change out schedule for the cartridges, a cleaning schedule. In general, respirators should be inspected for their basic function prior to each use. They should be cleaned. They should be stored in a bag or maybe a Rubbermaid container that has your name on it. We don't want to get them confused with anybody else. And then fit testing. All respirators that rely on a mask to face seal need to be annually checked, initially and then annually, with either a qualitative or a quantitative method to determine whether the wearer has an acceptable fit. The qualitative fit test procedure requires or relies on the subject. They're going to taste banana, or they're going to smell banana oil, or they're going to taste Bitrix or saccharin. Maybe some of you have done that before, where you get underneath of a hood and we put a bunch of this material inside and see if it breaks through the respirator, the test agent. And, so doing a qualitative or quantitative respirator fit test involves an instrument, right? And it's going to take the worker out of the equation because it's going to count particles inside and then ambient and be able to get a ratio to give you a fit factor. So, what determines that acceptable fit and what type of procedure you use? For the negative pressure air purifying respirators, you can rely on either a qualitative, that's the banana oil, or the quantitative, which would be an actual piece of equipment that counts particles. That procedure for exposure levels less than 10 times the occupational exposure limit. Maybe it's wood dust, maybe it's formaldehyde, maybe it's something else. But if it's 10 times or less than 10 times the occupational exposure limit, you can rely on either one. Any exposure level that's greater than 10 times the exposure limit, you have to rely on quantitative fit test procedures. And again, these are limits set by OSHA, these permissible exposure limits that are found in 1910-1000. So we would have to do a fit test on that worker depending. You know, I think I was muted there for a second. Jamie, can you hear me?
Yeah, I got you. Sorry about that.
Okay, somehow, yeah, that's okay. Written program. So the requirements for the written program entails a great deal of pre-planning. And that's important because it gives you time to think out, the selection and the medical fitness and the maintenance and the training and the fit testing and all the things that are involved. Of course, that program is going to be a working document and can continuously be improved as changes are made. But like all these things, we have to have a written respiratory protection program. And then the last thing that I want to cover on this is voluntary use of respirators. So I know a lot of companies allow workers to wear respirators voluntarily, and that's fine. Workplaces who allow their employees to wear respirators on a voluntary basis when not required by OSHA regulations or by the employer, they at least have to implement limited provisions of that respiratory protection program. And so when that filtering face piece, for example, like an N95 respirator, the ones that a lot of us have been using during COVID, when that's used, and the employer must provide a copy of Appendix D of the 134 standard. For all other voluntary users, especially, beyond that filtering face piece, we're going to have to, make sure that we're following the medical fitness and the proper maintenance procedures, even with voluntary use. So I just wanted to throw that out there. So respirators is a big deal. If you can engineer out the problem, the hazard, the exposure, that would be great. And then we don't have to wear these respirators, but not all the time can we do that. Number 9 on the list of the most frequently cited violations for the wood product industry is our wiring methods and components and equipment for general use. This is found in subpart S, and it's 1910-305, something I see often when I go out in the field. But they said this standard really just sets out the requirements regarding wiring methods, right? Components, equipment for general use. If we have, anytime we have conductors entering a cutout box or a cabinet or a fitting, they have to be protected from abrasion. So we use conduit, is nice to use. The openings through which the conductors enter have to be effectively closed. If they're missing knockouts, in other words, we want to put a knockout cap and make sure there's nothing open on those boxes or those outlet boxes and so on. Pull boxes, junction boxes, all that kind of stuff. We have to have them covered, right? And we know that any switches and those kind of things we have to have covered too. These pictures here that I have on this slide are pictures that show all of this, right? The one in the upper left shows an electrical service being open, I'm guessing because it's hot and it was overheating. Maybe too much amperage being drawn. Maybe it's, too many wires in there. For whatever reason, it's now exposing a worker to an electrical source, right, of energy. So that's not a good thing to be doing. Of course, the one on the right, upper right, with our panel boxes, we have some knockouts that are missing. I dare you to stick your fingers in that hole. So again, we know the outcome of that. We want to go ahead and have these knockouts filled. Of course, having missing outlet covers and switch covers in the bottom 2 pictures, not good at all. And at the one on the bottom right, it's actually being used as an extension cord. So they've taken a box that they've bought, a metal box, and they've put in a flexible cable on it. And now they're letting that lay on the floor and they can plug in a couple things to it. Definitely a violation, right? Because the manufacturer of that metal box did not intend the box to be used free floating, right? Not mounted to a wall and on the floor. So we have to make sure that we're using the equipment as the manufacturer specifies. That's a big part of it. And that all of our electrical energy over 50 volts is covered, right? In robust boxes, and we're following the general wiring requirements. I should mention here about flexible cords and cables. So we're talking about extension cords. OSHA does allow these to be used for certain things, like for fixtures and lamp holders and those kind of things. But they don't allow those to be those flexible cables to be installed permanently as a substitute for fixed wiring. So we've all seen it. We staple an electrical or a extension cord around the facility, on the wall, through a door, through a window, to power the vending machine outside or whatever it may be. Or we staple it or we twist tie it. As soon as you fix it to something, it's now being used as permanent, right? It's more of a permanent use. The standard talks about 90 days on extension cords, and they shouldn't be affixed to anything, right? These are to let our our summer events come into your small towns, carnivals and stuff, to put flexible cables all around for a week or so to allow us to use our shop floor fans for 90 days. So that's what that's all about. But I'd watch extension cords. That's a big area, and definitely keep those unattached to anything. The general requirements for all machines is number 8. And this, if you remember, machine guarding was nearly 22% of the overall general industry requirements. So what this is saying, this is our 1910-212 standard, and it talks about one or more methods of machine guarding shall be provided to protect the operator and other employees in the machine area from the hazards, such as those created by the point of operation, the ingoing nip points, the rotating parts, flying chips and sparks, that kind of stuff. Easy to cite, because anytime we see something moving that we can get into, it's going to be cited, right? We need to keep our machines guarded. What needs to be guarded as the point of operation. And this is where the work's being done, right? This is where your drill bit, your saw blade meets the wood, right? The stock that you're cutting. And that has to be guarded. All the power transmission points, the pulleys, the gears, the belts, all of that has to be guarded. You can see some of these pictures here where we have some unguarded pieces of equipment, including abrasive grinders. So also any moving part of a machine. So whether it rotates, it reciprocates, or there's transverse motion, again, we need to be looking at this stuff and guarding it. So that's really, if you can see it and you can think about getting your hand into it, it needs to be guarded. Now in the wood industry, especially like in a sawmill, a lot of times we guard by distance. So we can put things 8 feet or higher, or we can put a pedestal out where the operator will work, and in the blade so far from us, we put people in control rooms and so on. So that can help. We know that our drill presses, just as an example, we have to guard the chuck, right? And this is a good example of a chuck guard. It's been in the standard forever. I see a lot of citations on this, and this would apply for milling machines, for drill presses like this, a pedestal drill press, anything that has a rotating chuck. And so it's a Lexan shield of some sort that wraps around after you get the work set up before you start to use the equipment. The other one I see oftentimes is whether it's a vertical, in this case, this is a horizontal bandsaw, but it could be a vertical just as well. You can see all the arrows pointing to the excess amount of blade, right? There's a blade that runs across there. And really, we should only have the blade exposed right here between the points that you're going to be doing the cutting. All the stuff on the left needs to be guarded, right? So they would say too much blade exposed. A worker could get their hand caught in that blade. And so that would be the violation there. And then, this is an unguarded install on a trimmer table. Again, we might be guarding by distance, but a lot of times, a worker is going to be in this area. And so we want to look for these things. We want to try to guard them in some form or fashion, whether it's a fixed guard, whether it's a guarding by distance, whether it's a light curtain or some other technology. This is a tabletop saw. I just showed sort of the top portion of the blade, but this is an unguarded blade. There was also a cord cut with a splice, and then the grounding conductor is missing. So 3 things on this one table saw. We also see that maybe it doesn't have a kickback, pawl or a riving knife to keep that, to try to deny access to the back of the blade when we're concerned with kickback. So it's something else to look at. Unguarded belt and pulley. We got to watch under our tables, under our cabinets, make sure that we don't have a power transmission apparatus that's lurking underneath that our workers could get stuck in. So that's just a picture to show you what that might be. And then finally, we can use things like double hand palm buttons. We can, again, use pedestals. We can use enclosures to try to keep our workers away from these dangerous moving parts. And we definitely don't want things that look like this. And this is chain and sprocket. Obviously, we got a couple pinch points, just like a belt and pulley, just like rack and pinion. All these things can cause problems. And we have to do more than just caution tape. Number 7 on the list is sort of interesting that we have that the OSHA standards in 1910 general industry have the 265 standard, which is for our sawmills. So this is the industry specific standard that are on sawmills. And we know that working in sawmills, gosh, it might be one of the most dangerous occupations. It's up there in the US, right? So equipment poses numerous hazards itself, right? We have massive weights and falling, rolling, or even sliding logs as it goes through the debarker, into the saw and so on. All of that can be very dangerous. Obviously, the woodworking operations of the sawmill can also be hazardous. And as I mentioned in the beginning, particularly when machines are used improperly or without proper safeguards. Maybe we left the guard off, after we did some maintenance on a machine. So oftentimes sawmills do have missing guards, as shown in the picture of the unguarded belt and pulley. We know that noise exposure can also be hazardous to mill workers, and we'll discuss noise on the next slide. Lockout tagout's another big area for sawmills. Workers performing servicing or maintenance on machinery or equipment, they may be exposed to injuries from the unexpected startup, right? Or the release of stored energy. Therefore, we have to have lockout tagout procedures. These have to be equipment specific. And we'll talk more on this one too, because we're going to find out where this one falls in the top 10. Workers are exposed to not only noise, but also wood dust. So we have to be concerned with our dust exposures. Electrical safety, we talked about that, everything from missing knockouts to covers to extension cords being used as permanent use. And again, this picture here on the bottom shows an exposed electrical wiring on a 480 volt motor. So all of that needs to be enclosed. And then finally, walking working surfaces, our stairways or walkways or ladders or, all those kind of things. We have to make sure they're in good working order, that we have handrails on stairways greater than 4 risers, right? That the stairs can support, 1,000 pounds at minimal. And, so all these things are important. And heat stress. I mean, we don't have a heat stress standard per se, but there's some good guidance out in the California OSHA program that talks about heat stress. But, understanding it and having some things in place, because it does fall under the general duty clause of the OSHA Act of 1970, that we have to keep our workers safe and healthy. And even though we don't have a standard, heat stress is one of those things that we should be doing. Number 6 on the list, we're working our way down. Noise exposure in the wood product industry. This was number 6 cited, and this is 1910, 95. Definitely loud in the wood industry, right? You get into cabinet manufacturing and those kind of places, woodworking, it's not loud everywhere, right? We might have some loud parts in the mill and some spray areas, but overall it might not be as loud in the assembly and fabricating areas. So at any rate, I was trying to think, what does it feel like to have hearing loss? And well, this is one way to try to explain it, what it feels like in words. It's tough to tell somebody what it feels like. So if you have a hearing loss, this is what you might hear when someone's talking to you. And I challenge anybody on the call to read this to me. You can unmute and read this to me, which we know it's hard to hear, right? Because we're missing parts of it. And the thing is, if we had normal hearing, we might hear this, that, we believe that safety is number 1. So hearing loss is definitely something that's probably not as frightening as amputation, but it's definitely can be debilitating. It is 100% preventable, but once you have it, it's irreversible. So we want to make sure that we protect our ears. We know most of the production area, especially in a sawmill, are going to be well above 85. 90 decibels being the OSHA permissible exposure limit for an 8-hour time weighted average. You can go above and below that, but at the end of the day, did it average out to 90 decibels? If so, you have to do engineering, administrative controls. If you're above 85, that's our action limit, 85 decibels. Once you're above 85, you have to take action, right? We have to have a hearing conservation program in writing. We have to provide hearing protection and ear muffs, maybe 3 forms of earplugs and 1 form of ear muff. We have to require that people wear this PPE in the workplace. We have to try to engineer out the noise. We have to do audiograms annually and initially. But first we have to monitor, right? We monitor places all the time. And that's how you really put science behind it and say, okay, it's greater than 85, it's less than 90. We have to have a hearing conservation program, but at least we're not exceeding the 90 decibels. And you can make decisions based on that. It's all about noise-induced hearing loss. And noise-induced hearing loss is the hearing loss caused by the droning of the equipment. And not to go into a full explanation about hearing and the anatomy of the ear, this is actually the inner ear. And this slide shows the cochlea, which is where we interpret sound. It's a fluid-filled, snail-shaped organ that has sort of eyelash projections, which are sensory cells, I guess to make it easy, cilia. And this is a healthy ear. Now, if you're repeatedly exposed to levels above 85, and really in some cases, 3% of us are at excess risk at 80, but say 85 because that's the action limit, eventually you're going to end up with some hearing loss, right? And you might look like this. And again, these little sensory cells, we hear from 20 to 20,000 hertz. And depending on where these are missing, you will no longer hear that part of speech or that part of the frequency spectrum. It starts at high frequencies, quickly moves down into where we converse, 3 to 4,000 hertz range. But once this damage is done, you're not growing any more hair cells, right? The damage is done, it's done. And so we want to pay attention to that. And that's why we implement hearing conservation programs. And this is really just a quick overview of it, but you want to monitor first, what are we exposed to on an 8-hour day? If you're above 85, we have to have a hearing conservation. We have to do audiometric testing. That'd be a little hearing test that you hear a beep and you hit a button. It's called the real ear at threshold test. We want to select hearing protection that meets our levels and gets us down to a safe level. And then we want to train and educate our workers on that. There's some record keeping and some other things. And we actually do fit testing for hearing protection. If that ever comes up as an issue and you want to train somebody on how to wear it correctly, just like respirators, we can fit test our hearing protection. Number 5 on the list of the wood product would be mechanical power transmission apparatuses. Now we find these in 1910 to 19. This is in the machine guarding standard, and it's in subpart O. All belts, pulleys, gears, shafts, moving parts, they have to be guarded. That's really what it's all about. And typically we want to use, we can use distance. Again, if we can get these high enough off the ground and away from people, that's one thing. We can also use fixed guards like this one on a belt and pulley. But the end story is they have to be guarded, and you can't get your fingers into the pinch points and the parts that are moving. So look for those things. We see those often. Number 4 on the list would be woodworking machinery requirements. So this has its own little area too. And it goes through table saws and band saws. And this is 1910 to 13 in the machine guarding standard, subpart O. And we know that, with woodworking equipment, it has really the same hazards as any other type of equipment. Woodworking equipment can have kickbacks, again, where that stock may be kicked back at the operator. Fire and explosion hazards because of combustible dust. We also do dust hazard analysis for companies, if that's something of interest to anybody. In addition to the point of operation, the moving parts and the electrical hazards that are associated with equipment. Woodworking also has a lot of health hazards, whether it's noise or vibration or wood dust, or even the chemical hazards when you're in the finishing area or assembly where you're using glues and adhesives and different primers and things like that. There's definitely an exposure. Some of those could end up being to formaldehyde, to silica, depending on the types of primers and coatings that you're using. So we want to look at our safety data sheets for that. Just want to show you some pictures of these. A lathe chuck guard. Obviously, again, we have a rotating chuck. We should guard it. Oftentimes, I see these in that position, whether being used or not. And so it's always important that we're using them, that it's equipped with that, and it's being used properly. This is a picture of a bump or an end sander. And as you can all see, there's definitely a pinch point there on the end. It needs to be boxed in and enclosed where we can't get our fingers into that area. Also, the rest table needs to be tight against that sanding surface so that we can't get caught down between. We already mentioned pedestal drill press. This one does not have a chuck guard, right? So that would be a violation. Tabletop saws, I mean, this one has it all, right? No guard, probably no kickback pawl, no, I don't see any arriving knife, which would sit right behind the blade again. Those two things help keep that wood from kicking back. So got a lot of dust and debris on the table, probably not good, right? Housekeeping is not good. Let's move on to number 3 here on the list, the wood product industry top 10. And this would be our powered industrial trucks. Every place, most manufacturers, I should say, have a forklift truck on site. And, we want to make sure that our workers are, one, authorized by the company to actually operate that truck. So we need to do competency training, and that would include our classroom and hands-on evaluations. And that would authorize that worker at that point, if they pass both the classroom and the hands-on, to operate the truck. And initially, you got to do that training. And then every 3 years, you would reevaluate that worker. You don't have to necessarily send them through the classroom again, but you have to reevaluate them unless you have a near miss or something happens within those 3 years that requires some type of pulling them out and training them again. And I have there who's certifying the training program. I will tell all of you, and maybe you already know this, there is no such thing as a certified forklift trainer. I'm not certified. Most people there, I don't even know if you can get a certification. That comes from the 1999 standard when they talked about the employer shall certify. And they're certifying by making sure the operator has a classroom training and a hands-on evaluation. And so if you're familiar and competent with fork trucks and you know how to operate them and you know about the standard, you could be teaching your forklift training to your workers. And keep in mind, OSHA does not certify anything. So there's no such thing. What it comes down to is your workers would become authorized. And just like we do 10 and 30-hour general industry and construction training classes, we are authorized to do those. We're not certified in that sense. So it's the same thing. I just wanted to throw that out there. I think also making sure that everyone's trained before they operate, make sure they're wearing seat belts. That's a hard one to get people to do. Telling them if they get off the truck, they got to have the forks to the floor. The disengagement means in neutral, the emergency brake set, the key in the off position. Of course, pedestrians have the right of way. Oftentimes in our wood mills and sawmills, and we may not see everybody as we're maneuvering through with a forklift truck. And we want to keep our forks low, 2 to 4 inches if you can. Outside in a yard, you might have to raise it up a little bit, but it's keeping everything at reasonable speed is important too. So you would teach that to your workers, and that sort of meets that standard. These pictures here, show a lot of different unsafe acts or behaviors, definitely a couple of them. And then I just want to throw out there that we should never find ourselves up on the forks of a forklift unless we have an operator and we have an approved man basket that we have fall protection and so on. So if you buy a man basket that's made for that purpose, you can use it. If you fabricate one, even though it might be the best one in the world, I don't think it meets the standard in that. Number 2, so we're working our way up. Guess what? Hazard communication, right? Chemical hazard communication. Number 2, just like in the top 10, right, of the general industry, it was the biggest standard that was violated. And this is chemical hazard communication, 1910, 1200. Some key points here, that chemicals can be solids, they can be liquids, they can be gases. We have to get our workers to maintain labels. on primary containers. So these are the containers that are coming into our companies from manufacturers or importer or distributors. And they're going to have a label like the sample label here. This is called the Global Harmonization System label, GHS. And, it has 6 components on it: the product identifier, the supplier, the precautionary statements, the hazard statements, the pictograms, which everybody should have already done training on, the signal word. It can be danger or it can be warning. There's only 2 of them. And so it has to have those 6 different components on that. We want to teach our workers to read that label. As far as secondary labeling goes, this is if we're going to take a container and go get some material out of a bulk storage tank. We just want to transfer that information. It's oil, used oil, or it's WD-40 and it's flammable. We just want to write that on our container, make sure everything is labeled. That's the key. You want to refer to your safety data sheets. And again, keep in mind that if you can smell it, you can taste it, see it, feel it, you're being exposed to that chemical. Good news is the dose makes the poison. So depending on how much, a lot of times it's okay, right? Our bodies do a great job with like wood dust. We have a great filtering mechanism in our lungs that can bring that particulate back up to the top of our lungs using the escalator process, little hair cells that are bringing those little chunks of pieces of wood up to the top. And we'll cough it up or do other things, right? Swallow it. But think about how you're being exposed to those chemicals, whether it's through inhalation, absorption, injection, or ingestion, you eat it. Think about that, the routes of entry, and think about what you're being exposed to. Also, I mentioned that all workers should have been trained by 2013 on these pictograms. This is all part of that global harmonization system that OSHA put in place back in 2013. What do these mean? And it's something to train your workers, make sure they're aware of these different icons. If you look at this picture here, it's an unlabeled container, right? And I think most of us know that. It's these spray bottles, whether they're from Ace Hardware or Lowe's or Home Depot, we have to label them. Right, we have to put what's in it, and then we have to have the hazard, if it's flammable or if it's an irritant, whatever it may be. So let's work our way down to the number 1. Finally, this is what we've been waiting for, so give me a drum roll. The number 1 most frequently cited violation for the wood product industry is the control of hazardous energy. This is our lockout, tagout program. You find this in 1910-147. This applies across the wood industry, right? Anybody that has to perform maintenance or work on a piece of equipment, and you have to put your hands or your body in the point of operation, we have to make sure and be certain that that equipment is at 0 energy, active energy, stored energy. It has to be at 0. And so big program. And that's why, really important. Average lost work days on this one's 24, and these aren't days. Right? Usually these end up being amputations and so on. But hazardous energy control, again, what do you have to do as a company? We got to have a written program. We got to develop equipment specific procedures. It should say debarker. It should say molder, whatever it may be, edge bander, whatever you have that's beyond cord and plug, we have to have a procedure for it. And these procedures should be periodically reviewed. They talk about a periodic inspection. That means annually. We have to somehow certify or write a letter that says, yeah, we looked at all these. They all still apply. We haven't added anything new. And then there's a training component. And the standard really doesn't call for continuous training, but you have to train them once really good. I would definitely recommend training every year, but you have to train your affected people. These are ones who work around this lockout tagout event. And you have to train your authorized people, right? These are your maintenance workers who are going to be authorized to apply locks and tags and do the actual maintenance on that piece of equipment. This is a big deal. If you haven't done anything with lockout tagout, you should definitely get this one under control. Really important. This is a picture of it. We got locks and we got tags. And if you look real close in this picture, you'll see the locks haven't even been snapped shut. that defeats the whole purpose, right? Each worker who's going to be working on this system should have a lock, right? So if there's two workers working on it, we should have two locks, and they should be locked. And until the last person leaves, right, that system should be protected. This is you can come up with, there's a lot of flexibility in this standard to come up with methods to do this, to meet the goal of the standard for your company. So that's a good thing too. Some places use group lockout tagout boxes where everybody puts their lock on the box, and there's one set of locks out on the equipment. And until you remove your lock, nobody can get into that lock box to get on that equipment. But at any rate, really important standard, program, training, lockout tagout procedures for each piece of equipment that you have. And it has to consider all your energy sources like electrical, pneumatic, hydraulic, gravity, steam, whatever it may be. You have to get those to zero energy. So, we took a poll question earlier. After seeing this, do you plan to start, or are you going to continue to conduct your routine compliance safety audits of your workplace? Maybe we'll see a little, 100% so far. That's good. And that's really the goal of this, is to get people thinking about unsafe conditions in the wood product industry, right? There's a lot of hazards, and it's good to do audits. It's good to do inspections. We do a lot of what we call mock OSHA inspections, where we'll come in and we'll have an opening conference and we'll do the full-blown inspection, just like an OSHA compliance officer, and provide a formalized report to you. And so that you can make those changes and updates on everything that we may find. So we got about 71% of you saying you're going to continue on. It might be just a tad bit higher than what we had earlier, and that's okay. But I would, be aware of these and be looking around for safety and health hazards in the workplace. In conclusion, we reviewed the top 10 most frequently cited violations for the wood product industry, and it was at a very high level. And I'm sure a lot of you have some questions and maybe need further clarification. Feel free to reach out by, calling me, calling our team. Check out the OSHA's woodworking, logging, and sawmill e-tools. They're great overview of the standards and talks about hazards and solutions. And just feel free to reach out to any of us. In fact, I mentioned in the beginning about a checklist, the compliance checklist for what we just covered. And I've put together a checklist that I'd be glad to share with you if you want to email me your email address, like send me an email with your contact information. I'll shoot back the wood product industry safety compliance checklist that I generated from the top 10. And that would be a good starting place to look at all those different things and make sure you're complying with them. And if you have questions, again, feel free to reach out anytime. We're always here. So I do appreciate you joining me today. Again, don't hesitate to contact me or anybody on the team. And I'll just open it up for questions. We're at what, 52 minutes or so.
Yeah, we got a few minutes here for questions. We got a great comment from Richard Lemons in the comments for everybody about fork trucks, if you want to take a look at that. Also looks like, does the WVU Industrial Extension conduct compliance audits, was a question.
Yeah, so we do compliance audits, and one way we do them is the mock OSHA inspection, like I mentioned, but we also do what we call an initial health and safety consultation, which is just where we come in and we can do a walkthrough with you, and it's a more informal, I guess, project than the mock OSHA inspection. You won't get back a report, but you will get action items, and we would point out to you things that we see that are not in compliance. So, we'd be glad to help. Love going to sawmills. I love going to dimension mills, even cabinet companies, any of those kind of places that are just fascinating to me. So, feel free to reach out if that's something that you'd be interested in having done.
Okay, great. I've got, during the presentation, you mentioned noise and hearing conservation. What triggers the need for hearing conservation?
Yeah, so the big thing there is, I think you have to monitor first. That's a good question. I know we talked about that quickly, but we have to do some noise monitoring on our workers to get a baseline, right? So what noise monitoring is we wear a dosimeter little microphone up on the shoulder and we work our normal shift. And at the end of the day, the end of the 8 hours, 10 hours, whatever it is, we look at the data and we get at what we call an 8-hour time weighted average. We can then compare that number to the OSHA permissible exposure limit, which is 90 decibels. So if we come in at under 85, like 84 or under, that means we don't really have to have a hearing conservation program per the law. I'd recommend if you're 80 or above, you should have one, but compliance wise, 85 is the number. If you're between 85 and 90, we have to trigger our hearing conservation program. So that's our training, our monitoring, our audiograms annually and initially. Same thing with training, that's every year. We have to offer earplugs, multiple types, and at least one pair of earmuffs. And then if you're above 90, that would trigger you're out of compliance with that. So you want to find that ahead of time, obviously. And then you want to try to reduce that noise using the hierarchy of controls that we talked about. Either eliminate, substitute, engineering controls are most likely. And then you might have to do some rotation. You might have to take breaks in quiet areas and try to get that number to be reduced, and ultimately relying on the hearing protection if you can't engineer out the sound. But noise is interesting. You can do a lot with it. And, if you can get a 3 decibel decrease, well, that's highly significant, right? That's a big deal. You've cut the noise in half. And oftentimes we can do that. So good question.
Yeah, and I got another one here, John. This is a good one. Does homemade guarding comply with OSHA requirements, or does it need to come from an approved source?
It depends on what the homemade guarding looks like. If you're talking about chicken wire and duct tape and ventilation pipe, no. But I'm assuming you mean rigid steel. If the guarding is just as high quality as the machine itself, you can make your own guarding. And in fact, a lot of companies do, because not all the equipment comes guarded, right, in the US. And we may use that equipment differently than what was anticipated, and we have to guard it. So I would just say that you can do that. You just have to make sure that that guarding is substantial and that it fully encloses and meets the requirements of the guarding standard. It does not have to be approved by a manufacturer. In fact, I've seen people make guarding out of wood, plexiglass. It depends on the equipment. But if it's a machine, you can make your own if it's substantial.
Okay, great. I don't see any more questions. I wanted to make sure everybody was aware that we'll be sending a recording of this out probably early next week, along with the slides. I know John cited a lot of different standards and things that probably would need a quick review if you're going to look for it. So don't be looking for that, and don't hesitate to reach out to John. His contact information is there. John and everybody on our team, we love to hear from our manufacturing partners. So please just let us know what's going on and what we can do to help you. And that's all I've got. So thanks so much, John.
All right. Thank you. And everyone have a good day.
All right. Bye.